Hello all, this is Sagarika. Welcome to SAGU'S Math. Today's topic is method of induction, third part of method of induction. Already two parts are we already discussed. Okay, now move to question number, this is question number 11. Okay, similarly same process as before math. Let Pn is our statement 16 to the power n plus 10n minus 1 is divisible by 25. Okay, divisible by 25. Step 1, there are 3 steps. Step 1, to prove n is equal to 1, it is true. Then assume that for n equal to k, pk is true. And then we have to show pk plus 1 is true. These are the procedures. Okay. For step 1, for n is equal to 1, p1 is equal to 16 to the power 1 plus 10 into 1 minus 1, which is equal to 26 minus 1 equal to 25. Know that 25 is divisible by 25. That means p1 is true. Okay. 25 is divisible by 25. Okay. Is divisible by 25. Okay, so p1 is true. Next step, assume that pk is true. Okay, pk is true. That means 16 to the power k plus 10k minus 1 is divisible by 25. Is divisible by 25. Okay, listen. If we write 25 is divisible by 5, that means 5 into some. Okay, question 5 into 5. That means we can write 25 equal to 5 into 5 in place ever. In place, we can write 5 into k. That means multiple of 5. 25 is divisible by 5. That means 25 is multiple of 5. That means we can write 25 equal to 5 into k, where k is equal to 5. Or listen, 27. 27 is divisible by 3. We can write 27 is equal to 3 into k, which is equal to in place k. We will write 3 into 9. That means k is equal to 9. Similarly, this is divisible by 25. That means we can write 16 to the power k plus 10k minus 1 is equal to 25 into some multiple m, where m belongs to z. Okay. Z means integer set. Next, move to step 3. Step 3, assume step 3. We have to prove that pk plus 1 is true. That means in place of n we will put k plus 1. That means 16 to the power k plus 1 plus 10 into k plus 1 minus 1 is divisible by 25. Okay. That means we have to prove 16 to the power k plus 1 plus 10k plus 10 minus 1 is equal to multiple of 25. That means 25 into p, where p belongs to z. Okay. Taking this as equation 1. From equation 1, we can write 16 to the power k is equal to 25n minus 10k plus 1. Okay. Now, here from LHS, 16 to the power k plus 1 plus 10k plus 10 minus 1, which is equal to 9, is equal to 16 to the power k into 16 plus 10k plus 9. Okay. from equation 1, 16 to the power k. In place of 16 to the power k, we can write 25m minus 10k plus 1. Okay. Plus 10k plus 9 into 16. Which equal to 16 to the power k. In place of 16 to the power k, we can write 16 into 25n minus 10k plus 1 plus 10k plus 9, which equal to 16 into 25n minus 16 into 10k. 16 into 10k plus 16 into 1, 16 plus 10k plus 9, which equal to 16 into 25m minus this equal to 160k, this equal to plus 10k, minus 160 plus 10, which equal to minus 150, which equal to minus 150k plus 16 plus 9, which equal to plus 25. Now taking 25 as common, which equal to 16m. 6 as 150, so 6k plus 1. That's equal to 25 into P. We can write this into P, where P is equal to 16m minus 6k plus 1. Hence, which equal to right hand side. Okay. So, this is divisible by 16 to the power n plus 10n minus 1 is divisible by 25. Hence, proved by method of induction by 25. Now, next to do similar type of math, which is question number 12. Okay. Question number 12 is 5 to the power n minus 1 is divisible by 4. This is divisible by 4. Okay. Good. Similar same process, let Pn such that 5 to the power n minus 1 is divisible by 4. Okay. Step 1. For n is equal to 1. P1 is equal to 5 to the power 1 minus 1, which equal to 4. We know that 4 is divisible by 4. Yes or no? Yes. 4 is divisible by 4. So, P1 is 2. Okay. Next step 2. Assume that P, K is true. Okay. That means 5 to the power K minus 1 is divisible by 4. That implies 5 to the power k minus 1 is some multiple of 4. That means we can write this equal to 4 into m, where m belongs to integer set z. Now we can write 5 to the power k is equal to 4m plus 1. Yes. Okay. Next to step 3. Okay. Step 3, we have to prove that pk plus 1 is true. That pk plus 1 is true. That means that is to prove 5 to the power k plus 1 minus 1 is divisible by 4. Okay. That implies we have to show 5 to the power k plus 1 minus 1 is some multiple of 4. That means the multiple is like p. Okay. Now, 5 to the power k plus 1 minus 1, which equal to 5 to the power k into 5 to the power 1 minus 1, which equal to 5 into 5 to the power k. In place of 5 to the power k, we can write this equal to 4m plus 1 minus 1, which equal to 4 into 5m plus 5 into 1, 5 minus 1, which equal to 4 into 5m plus 4. That's equal to 4 into 5m plus 1, which we can write 4 into p, where taking p is equal to 5m plus 1. That means some multiple of p. Okay. So, 5 to the power n minus 1 hence is divisible by 4 for n greater than is equal to 1. Okay. Question number 13. Prove 2n factorial is divisible by 2 to the power n. Okay. For n greater than is equal to 1. Similarly, same process, but first we have to know what is factorial. Okay. N factorial means which equal to n into n minus 1 into n minus 2 up to dot dot is equal to 1. Up to 2 into 1. Okay. 5 factorial is equal to putting in place of n equal to 5. 5 into 5 minus 1, 4. Into 5 minus 2, 3. Into 5 minus 3, 2. Into 1. Up to this. This equal to factorial. Okay. Got it? Now, let's move to, okay. Let Pn such that 2n factorial is divisible by 2 to the power n. Step 1. For n is equal to 1, 2 into 1. In place of n, we will put 1. 2 into 1 factorial, which equal to 2 factorial. That's equal to 2 into 1, which equal to 2. Is divisible by 2 to the power 1. In place of 1, we will put 1. Okay. That implies 2 is divisible by 2, which is right. So, P1 is 2. Okay. Next step. For n is equal to k, assume that pk is 2. Assume that pn is 2. Okay. That means 2k factorial is divisible by 2 to the power k. That implies 2k factorial is multiple of 2 to the power k, which we can write 2 to the power k into n, where n belongs to integer. That means some multiple of 2 to the power k. Okay, 2 to the power k into n means this. Okay, don't write this in your exam. It's for your understanding. This equal to take equation 1. Now step 3. For n is equal to k plus 1, we have to prove Pn is true. Okay. That means 2 into k plus 1 factorial is divisible by 2 to the power k plus 1. Okay. Now that is to show 2 into k plus 1. which will be 2k plus 2, 2 into k, 2k, 2 into 1, 2. Factorial is equal to some multiple of this. That means 2 to the power k plus 1 into p, which is equal to 2 to the power k into 2 into p. Okay. Simplifying 2 to the power k plus 1 equal to 2 to the power k into 2 to the power 1. Now from left hand side, 2k plus 2 factorial, which we can write, that means multiplying from this number to its previous number. 2k plus 2 into 2k plus 1 into 2k factorial. Okay, we can write this. Now, in place of 2k factorial, from equation 1, we can put 2k plus 2 into 2k plus 1 into 2 to the power k into m. Okay, which equal to, now here we got 2 to the power k and 2 to the power k. Now to showing this is multiple of 2. Okay, that means 2 into k plus 1, from taking these 2 as common. 2 into k plus 1 into 2k plus 1 into 2 to the power k into m. Okay, which equal to, excluding 2 to the power k and 2, 2 to the power k into 2 into p, where p is equal to k plus 1 into 2k plus 1 into m. Okay, which equal to RHS. Yes, sir. Okay, so Pn is for n greater than is equal to. Now move to question number 13. Question number 13 is to prove 10 to the power n plus 1 plus 10 to the power n plus 1 is divisible by 3. Is divisible by 3. Okay. Proof. Similarly, let Pn 10 to the power n plus 1 plus 10 to the power n plus 1 is divisible by 3. Okay. Step 1. For n is equal to 1, P1 is equal to 10 to the power 1 plus 1 plus 10 to the power 1 plus 1, which equal to 10 square 100 plus 10 plus 1 is equal to 111. Now sum of this equal to 3, which is divisible by 3. That means this is divisible by 3. Okay. So P1 is step 2. For step 2 means assume that Pn is true for n is equal to k. Okay. That means 10 to the power k plus 1 plus 10 to the power k plus 1 is divisible by 3. That implies 10 to the power k plus 1 plus 10 to the power k plus 1. Since divisible by 3, that means multiple of 3. We can take 3 into m, where m belongs to z. For all m belongs to z. Okay. From here, we can find 10 to the power k plus 1 equal to 3m minus 10 to the power k minus 1. Okay. Now, step 3. Step 3, we have to prove that pk plus 1 is true. That means that is to show that implies that is to show 10 to the power. In place of n, we will put k plus 1. That means k plus 1 plus 1 plus 10 to the power k plus 1 plus 1 is divisible by 3. Okay. That implies 10 to the power k plus 2 plus 10 to the power k plus 1 plus 1 is multiple of 3. That means to check 3 into p, where p belongs to check. Okay. Now 10 to the power k plus 2, left hand side, plus 10 to the power k plus 1 plus 1. Right, 10 to the power k plus 2 is equal to 10 to the power k plus 1 into 10 plus 10 to the power k plus 1 plus 1. Okay, which equal to, we can write in place of 10 to the power k plus 1, 10 into 3m minus 10 to the power k minus 1 plus 10 to the power k plus 1 plus 1. Okay, which equal to 10 into 3m minus 10 into 10 to the power k minus 10 into 1 plus 10 to the power k plus 1 plus 1. Okay, which equal to taking 3. We can write 3 into 10m minus 10 to the power. Here power 1, here power k. Power will be a, okay, 10 to the power k plus 1. Here minus 10 plus 1, which will be minus 9 plus 10 to the power k plus 1. Here 10 to the power k plus 1 plus and minus cancel. Now from these two, taking 3 as common, 10m minus 3. Okay, 3 3s are 9. From these two terms, taking 3 as common, which equal to, we can write 3 into p, where p is equal to 10m minus 3. Okay. Synergize in your exam. Okay. A to the power n minus 1 is divisible by a minus b for any integer a and b with a minus b not equal to 0. If, listen, why here mentioned a minus b not equal to 0? Listen. When we divide a to the power n minus b to the power n by a minus b, if a minus b equal to 0, that means something by 0 does not exist. Okay, so the denominator can be 0. Okay, now move to proof. Let Pn such that a to the power n minus b to the power n is divisible by a minus b whenever a minus b not equal to 0. Okay, for n greater than is equal to. Okay, step 1, taking for n is equal to 1. P1 is equal to a to the power 1 minus b to the power n. Which equal to a minus b? We know that a minus b is divisible by a minus b because the number divisible by own self. Okay, always. So, now taking for n is equal to 2, P2 is equal to a square minus b square, which will be by the formula a plus b into a minus b. Now, this is some multiple of a minus b, which we can write this also is divisible by a minus b. Okay. So, first step is proof. Okay. Next move to step 2. Step 2, assume that pk is true. Okay, pk is true means a to the power k minus b to the power k is divisible by a minus b. That means a to the power k minus b to the power k is some multiple of a minus b. That means taking some multiple equal to n, where n belongs to integer. Okay. Now step 3. Prove that pk plus 1 is okay. That means that is to show a to the power k plus 1 minus b to the power k plus 1 is divisible by what? Is divisible by a minus b. Okay. That means to show a to the power k plus 1 minus b to the power k plus 1 is equal to multiple of a minus b into p. Okay. Where p belongs to z. Now, left hand side of this. A to the power k plus 1 minus b to the power k plus 1. Which equal to, we can write a to the power k plus 1 minus a into b to the power k plus a into b to the power k minus b to the power k plus 1. Okay. Or we can write this a to the power k into a minus a into b to the power k plus a into b to the power k minus b to the power k into b. That means breaking a to the power k plus 1 is equal to a to the power k into a to the power 1, which is equal to a to the power k. Now taking here common as a to the power k minus b to the power k. Here taking b to the power k common as b, a minus b. Now in place of this, a to the power k minus b to the power k, from equation 1, we can put a into a minus b into m. Okay. Plus b to the power k into a minus, which taking a minus b from both sides, comma, which equal to am plus b to the power k, which equal to, we can write this into p. Okay. Where p is equal to am plus b to the power k. Okay. So, or hence, a to the power k minus b to the power k is divisible by what? A minus b. Okay.